Bube. Hi there, my name is Stefan Bube. I'm with Iris, a producer of automatic passenger counting sensors, and I'm head of product management. Today I would love to bring you closer the value of precise raw passenger counting data. Since the beginning of the COVID-19 crisis, the demands on public transport changed dramatically. Before this, the requirements for a good counting system were designed to identify and to record many individual people at particularly high peak times and to provide reliable figures on the number of people getting on and off the vehicles. Crowded platforms and stops have been the challenges for the development of those counting systems. Operators in public transport are often indifferent to the technology that is used in their automatic passenger counting systems. This is quite understandable, as long as everything works. It doesn't matter how it works. This is especially true for passenger counting for revenue sharing purposes with systems that are currently available on the market. Various modern technologies provide a high and comparable counting accuracy. Today, the situation is different. We have to ensure that people on public transport can keep the necessary distance in order to minimize their risk of infection. Due to the risk, individual traffic has increased dramatically. Thus, the requirement has evolved from providing accurate counting data in well-filled vehicles to the demand to ensure that passengers are distributed in a balanced way and without mass accumulations within the vehicle or the transport network. In order to ensure trust in public transport, as a safe service provider, the demand for smart solutions and real-time applications for vehicle occupancy is growing rapidly. For such applications, operators need data, fast, reliable, and highly accurate. Of course, accurate passenger numbers are not enough to create a truly smart service in real time. Passenger numbers must be matched with learned probabilities, geodata, weather, and event data so that artificial intelligence can be created from that bunch of information. In order to be able to provide passenger counts with less storage capacity and fast transmission rate, it is important that the passenger counts doesn't require any plausibility corrections or any statistical voodoo. This means data can be transmitted and used directly because they are available with highest accuracy. As I said before, with the modern APC systems currently on the market, the various technologies provide comparably high counting accuracy, sufficient for later evaluation, even though the data are generated in complete different ways. The situation is different when it comes to occupancy of vehicles. In order to provide reliable live information for a passenger information system, high quality of raw data is required. From this point of view, it is interesting to take a closer look at counting technologies. With time of flight technology, TOF, that our counting sensor utilizes, distances are not calculated but measured. This is possible because the sensors send out their own light and outside of the visible spectrum. The sensor measures the time it takes from the emitted light beam to travel from the source to the object and back into the sensor. This produces a pretty precise 3D image of who or what is passing underneath the sensor. The sensor uses neural networks to classify objects. On the basis of taught-in data, people, bicycles, wheelchairs, prams are differentiated based on their specific characteristics. Even people in a crowd are no challenge anymore with that counting systems. Since well-implemented tough technology is not disturbed by environmental factors, there's no need to tweak the raw data afterwards or do any plausibility corrections. They already offer a very high quality as they come out of the sensor. This is exactly what becomes the decisive advantage when it comes to real-time information systems. Subsequent calculations of all kinds take up server resources and cost time. Excellent raw data, which are delivered without delay to the onboard computer, to a customer server, to a cloud service, provide a far better basis for the real-time calculation of occupancy levels. So much for the value of raw data quality, which of course also proves itself and pays off in other contexts, such as APC testing, capacity, route planning. When it comes to reliable occupancy rate display, another factor becomes decisive: technical robustness. Defective sensors leads to deviations in the occupancy rate display, which build up over time. It can happen that an empty bus is announced as an overcrowded one at the end of the day, just due to the defective sensor. To avoid such distortions, counting sensors should not fail. Due to single camera use in our sensor, we achieve an outstanding reliability. It is obvious that reliable information on the occupancy rate of vehicles is particularly valuable in times of pandemics. Valuable for passengers who want to minimize their risk of infection in public areas, but it's also valuable for transport operators so that they can offer their customers the most carefree transport possible, even in these difficult times. As our partner MTA New York did with the app My MTA, in the probably most urgent phase of the pandemics, passengers can track in real time how full the next bus on their route will be, which is pretty fancy. Or Concert Telematics with their solution for real-time crowding data on Melbourne public transport. Of course, the current pandemic is not the only reason for the increasing demand for real-time solutions. The issue of sustainability and zero emissions is also pushing the demand. Another project of our partner Metasoft in Lahti, Finland, with the CityCab project. For this UIA-funded project, they are linking various data in order to calculate the user's carbon footprint by an app, which is pretty fancy as well. Thank you for your attention.